Biomass energy, or bioenergy, is derived from organic materials such as plant and animal matter. There are several methods to convert biomass into useful forms of energy, including heat, electricity, and biofuels. Here are the primary methods. 1. Direct combustion. The principle here involves burning biomass directly to produce heat. The process includes biomass such as wood, agricultural residues, or dedicated energy crops being burned in a furnace or boiler. The heat generated is used to produce steam, which can drive turbines to generate electricity or provide direct heating for industrial processes or buildings. Applications include home heating, industrial boilers, and power generation. Next, pyrolysis. The principle is decomposing biomass at high temperatures ranging from 300 to 700 degrees Celsius in the absence of oxygen. The process involves heating biomass in a pyrolysis reactor, producing biochar, biooil, and syngas. The biooil can be refined into biofuels, while syngas can be used for heat and power generation. Applications include the production of biooil, biochar for soil amendment, and syngas for power generation. Finally, gasification. The principle here is converting biomass into syngas, which is a mixture of carbon monoxide, hydrogen, and methane, at high temperatures between 800 and 1000 degrees Celsius with a controlled amount of oxygen or steam. The process involves heating biomass in a gasifier, producing syngas, which can be cleaned and used to generate electricity, produce heat, or as a feedstock for chemical production. Applications include power generation, chemical synthesis, and hydrogen production. All right, let's dive into liquefaction. The principle behind this method is converting biomass into liquid biofuels at moderate temperatures and, high pressures. The process involves mixing biomass with water and subjecting it to high temperatures and pressures in a liquefaction reactor. This results in the production of biocrude, which can then be further refined into biofuels. The applications? Well, it's mainly used for producing liquid biofuels like biodiesel and biooil. Moving on to anaerobic digestion. The principle here is breaking down biomass in the absence of oxygen to produce biogas, which is mainly methane and carbon dioxide. The process involves placing organic waste, such as manure, food waste, or wastewater sludge, in a digester. Microorganisms then break it down, producing biogas that can be used for heating, electricity generation, or even as a vehicle fuel. The applications are quite broad, including biogas production for power generation, heating, and transportation fuel. Fermentation. The principle here is converting carbohydrates in biomass into ethanol or other biofuels using microorganisms like yeast. The process involves breaking down biomass such as corn, sugarcane, or cellulosic materials into sugars. These sugars are then fermented by yeast to produce ethanol. The ethanol can be purified and used as a fuel. Applications include the production of bioethanol for blending with gasoline or as a standalone fuel. Transesterification. The principle involves converting oils and fats into biodiesel through a chemical reaction with alcohol. The process entails reacting vegetable oils or animal fats with an alcohol, usually methanol, in the presence of a catalyst to produce biodiesel and glycerol. Applications focus on the production of biodiesel for use in diesel engines. Biorefining. The principle here is converting biomass into a variety of bio-based products, including biofuels, chemicals, and materials. The process is quite similar to petroleum refining. Biomass is processed through various physical, chemical, and biochemical processes to extract different components for producing fuels, chemicals, and other products. Applications involve the integrated production of biofuels, biochemicals, and bio-based materials. Each method has its own advantages and applications, contributing to a diverse and flexible approach to utilizing biomass for energy production.